If you're just tuning in, I appreciate you stopping by. In this video, we're going to discuss how to utilize RCommander to compute Poisson probabilities. Now, if you're interested in the mechanisms which are utilized to complete these calculations, or if you're interested in some of the attributes of the distribution or when it's appropriate to apply the methodology, you might want to take a look at the last video in the playlist, which is number 18 in the playlist series, and that will discuss the mechanisms, the attributes, and how to derive Poisson probabilities within the R programming language. But if you're only interested in utilizing RCommander to derive the Poisson probabilities, we will go through that now. So let's say that every Tuesday in spring for 8 hours, your web camera films for bluebirds which frequent your garden. You've counted these bluebirds, and over the course of the season, you have noticed an average of 12 bluebirds visiting your garden each day. What is the probability that exactly 8 bluebirds will visit your garden given the parameters of the experiment? So we're going to structure this in RCommander. I'm going to do a RCommander example, and then we'll look at the rest of the examples within the slides. So let me pull up the R. Now I've already have the RCommander package initiated, but however, if you wanted to initiate it yourself in your session, you could either run this code here, library, and then in parentheses RCMDR, or go to the packages tab and click to the left of RCMDR package. And it might take a moment or two to load, but once it loads, you should have the RCommander menu. So from the RCommander menu, we're going to choose distributions, discrete distributions, Poisson distribution, and then Poisson probabilities. Now our mean value, or our lambda value as it's known in the Poisson, is 12. So we're going to enter that value here and then click OK. We are met with the corresponding output below in the console, and I'm going to show this output in the slide since it's a bit difficult to see here, and I'll inform you how to then determine what's necessary to finish this particular word problem. So let's get out of our studio and let's get out of RCommander. So if you were having trouble seeing the steps, it's distributions, discrete distribution, Poisson probabilities. Our lambda value was 12 because that's the number of bluebirds which we typically see in our garden on average. And we're interested in exactly 8 bluebirds being filmed on a particular day. This was the output in the console that was generated by RCommander. And what we need to do is we need to count to 8. So 8 on the left is here. And then this decimal value here, that is the probability value which we are interested in, the probability value which answers our particular prompt. So the probability of the number of bluebirds visiting your garden being exactly 8 is 0.065. And then if you move that decimal point over 2 places, you come to 6.6%. Now you can determine how you want to handle significant figures, but you still need to move the decimal point over 2 places. You can do that by multiplying this value here by 100. And then from there, you should have the appropriate percentage. So 6.6% is the probability percentage of exactly 8 bluebirds visiting your garden given the other experimental parameters. Let's now compute the probability that the number of bluebirds visiting your garden is no more than 8. No more than 8, okay? So it could be 0, 1, 2, 3, 4, 5, 6, 7, or 8 birds. We want to know the probability that any of those events occurs. 0 birds, 1 bird, 2 bird, 3 bird, 4 bird, 5 bird, 6 bird, 7 birds, or exactly 8 birds visiting your garden, given the parameters of the experiment are in place. So for this, we're going to go to distributions, discrete distributions, Poisson distribution, and then Poisson tau probabilities. We're going to select lower tau is true because we're interested in 8 or less. Okay, 8 or less. So our variable value, our x value, is going to be equal to 8. The mean is going to be equal to 12 because that's our lambda value. That's the average number of bluebirds which we observe given the experimental parameters hold. And again, lower tau because it's less. So if you are to click OK then within RCommander, once you have come to this particular submenu, this is the code that will be executed by RCommander, and this is the output which you will receive. So if we move the decimal point over 2 places, we get to 15.5%. And if we are rounding that up, if we're not utilizing any significant figures, if we just want a whole percentage value, we would round that 5 to a 6 because the next value is 5 here, and we would get to 16%. So therefore, the answer to this particular prompt is the probability that the number of bluebirds visiting your garden being no more than 8 is 0.155 or rounded to 16%. So that is it for this particular video lecture. We're going to do one more as it relates to probability distribution types just to sort of drive the point home. If you were able to take anything away from this particular video, I'd appreciate it if you like or subscribe. That would mean a lot. And I hope that this is able to help you out for your research needs or your classroom setting. I hope you have a wonderful rest of the day. Take care.